2014, evolutionary biologist Monica Gagliano published a paper outlining an experiment she had conducted with plants. The subject of the experiment was a mimosa pudica, a Brazilian plant colloquially known as the sensitive plant. It earns this name because of how sensitive it is to external stimuli. The plant has fascinated scientists dating back to Darwin because it operates on a human timescale. If the plant senses touch, it immediately recoils into itself. The leaves on a given stem immediately fold together like a magazine. Gagliano conducted an experiment in which she created a device that would drop the plant 6 inches onto an absorbent piece of foam. She repeated this process 60 times. The first few times, the plant folded immediately, sensing a drastic change in its environment. However, after roughly 10 drops, the plant exhibited no change in behavior, registering that the drop did not indicate any threat. Wondering if this didn't indicate some kind of internal registration within the plant, but rather exhaustion on the part of the mimosa, she left the plant undisturbed for a week. When she finally dropped it again, it stayed completely open. She then left it dormant again, this time for a month. When she returned to drop it, not a flinch. Ecologist Suzanne Simard has been researching this phenomenon for over 30 years and has changed the way we think about forests. For centuries, Enlightenment scientists had observed the above-ground architecture of the forest, arriving at the conclusion that trees in the forest were competing with one another for resources. Simard conducted an experiment limiting the carbon intake of a young Douglas fir growing next to a young paper birch, whose photosynthesizing capacity was undisturbed. She was able to conclude, using a Geiger counter, that the trees were in fact exchanging nutrients. Simard discovered that mycorrhiza, meaning fungus root, is the communication highway through which conversations between trees like Douglas fir and paper birch take place. More specifically, through mycelial networks underground, the fibers of the mycorrhiza, interwoven in a symbiotic relationship with the roots of the trees. Information, as well as nutrient-rich carbon, is exchanged through mycelium, playing a role similar to that of the semiconductor or data transfer cable in modern electronic systems. The conclusion that trees are able to communicate and distribute resources equitably to one another changes the way we think about trees in the forest, rendering them not as competitors, but collaborators. Trees can send distress signals, warnings of disease, invasive species, and a number of other significant events. Elder trees, with the best access to sunlight, have the furthest mycorrhizal reach, allowing them to distribute carbon across a larger population. The largest living organism on Earth is not the blue whale or the aspen tree, but an Armillaria osteae fungal network in Oregon, spanning some 2,334 acres, or 1,665 football fields. Leafcutter ants build highways out of their urban centers. They can build up to 3 kilometers of highway a year, stemming from their colonies. They do this in order to safely travel outside of the colony and carry out their namesake, cutting leaves. Leafcutter ants are an agricultural species, possibly the first ever to appear on Earth. They collect parts of leaves as nutrients in order to raise their own fully domesticated fungus, which they have been doing for roughly 40 million years. A colony of leafcutter ants, numbering in the many millions, is capable of defoliating a mature eucalyptus tree overnight. The ants feed the fungus by cutting up the leaves they retrieve into smaller pieces, creating a mulch, and then introducing fresh fungi hyphae into that mulch. The ants organize themselves by size. Larger ants do the leaf cutting, whereas smaller ants keep the gardens, which are much more architectural than lateral, clean and clear. Some ants dedicate their lives to carrying out and maintaining the society's public health and safety infrastructure, taking different kinds of waste and bringing them 30 feet below the gardens to process, similar to how we humans compost. Were they not to have this infrastructure, disease from waste would likely wipe out the garden's fungi and subsequently the colony. Through its domestication, the relationship the fungus has with the ants has become symbiotic. The fungus relies on the ants for nutrients, and in turn, produces the ants' complete and balanced diet. Leafcutter ants do not have a centralized form of intelligence. Rather, their societies are evolved enough to where each ant is equipped with enough information to make the proper decision. No single ant's death can significantly alter society.